Good morning to our respected principal ma'am and all the teachers. I am Anurag Kaur of class 10.
And I am Sharnavushri Sharma of class 10. And today we are going to show you how we can terraform Venus quickly. As days go by, humanity is evolving rapidly. The change is so rapid that eventually we will run out of our resources and need to start searching for a new home. Most people say that Mars can be the best option for us humans to colonize. But is it? You see, Mars is a small planet with a toxic atmosphere, poisonous ground, and low gravity. If we truly need to colonize Mars, we would have to live underground, limiting the endless possibilities. Life on Mars would be quite depressing. Instead, a better option here would be Venus, which happens to be the deadliest planet in our solar system.
Venus at times is regarded as Earth's sister planet. Well, the conditions are not really the same. Venus has a high surface temperature that can reach up to 465 degrees Celsius due to the extreme greenhouse effect, which is hot enough to melt lead. Its atmosphere mostly contains 96% of CO2, which further makes the atmosphere 93 times denser than it is on Earth. It also rains sulfuric acid as it has sulfur dioxide clouds in its outer atmosphere. Our human bodies are not suitable for these huge amounts of pressure, nor the sulfuric acid rain, so we don't stand a chance. It really is a horrible planet to colonize. So why do it? Firstly, Venus is almost as big as Earth and has the same gravitational pull. You see, gravity is very important during the long-time space expeditions, as low gravity might affect our health in various ways. However, there is one bad thing. One Venusian day lasts for about 243 Earth days, but that too can be fixed.
Alright, before anything, we would need to cool Venus down to a suitable temperature and remove all the CO2 gas. The best option here would be the use of a sunshade. We are basically going to use mirrors that don't even have to be that massive. They can be as thin as a foil but should have a bit of structural support. We are going to use several pieces of angled mirrors so that the light from the sun gets redirected without falling on Venus. Venus has now started to cool down and will keep cooling down for another 1 or 2 centuries. The CO2 will slowly start to rain down as the temperature drops, creating massive CO2 oceans which will eventually freeze and the planet would experience its first ever snowfall. Venus is now completely frozen with a temperature of minus 81 degrees Celsius. The atmospheric pressure has dropped to only 3 bars and the atmosphere mostly contains nitrogen gas. The main challenge is yet to come. If we want to move any further, we would have to move all the frozen CO2 to somewhere else. One of the best options that can be suggested here is that we cut chunks of frozen CO2, blast it into space, and collect those chunks into a small moon. This process is probably going to take the longest time to be solved completely.
Okay, let us assume that all the frozen CO2 has been removed from the planet. Our next priority would be getting water. So, let's go to Jupiter's moon, Europa. Europa has twice the amount of water as Earth. The water appears in a frozen state and works in our favor as we are going to be able to transport it to Venus very easily. This is where space stations or skyhooks come in help. They are basically huge slings that can take a payload on both ends. This would make interplanetary travel way easier. We can use a number of robots to mine the ice and shoot them to the skyhooks. Similarly, we can have another skyhook at the receiving end, that is Venus, so that the ice can slowly fall to the ground in the form of snow. Now, to melt the snow and create water oceans, we would need to heat up the planet. Removing the sunshade would immediately fry one side of our planet. Instead, we can use more mirrors and create a sort of day and night simulation by letting in some sunlight This is the best option because we would be able to control the amount of energy we would be receiving. Now comes the most difficult part of terraforming, that is, creating a suitable atmosphere and adding some life to it. The atmosphere right now is full of nitrogen but devoid of oxygen. So, the first life form on Venus would be countless amounts of cyanobacteria. They can fix nitrogen from the atmosphere and produce more useful chemicals and nutrients. This will eventually prepare our oceans for complex organisms. On the surface, however, they would probably make the atmosphere breathable as they would carry out photosynthesis and produce oxygen that can support more complex life.
On land, we would need to make the soil by breaking down the rocks so that plants can grow on them. We can speed up the process with the strategical use of our resources, and slowly but surely Venus will turn green. It would take thousands of years more for the atmosphere to be breathable, but in the meantime, we would start creating small research settlements and study the different kinds of life at Venus. Maybe it's not that easy to terraform Venus. According to the Kardashev scale, everything might be within the hands of a Type 1 civilization.
A civilization that has harnessed all the resources available on Earth, but even for a Type 1 civilization, terraforming Venus will take a very long time. But when has that ever stopped us?
Hello everyone, I am Shagnik Bhattacharjee from class 9. Before saying anything else, I would like to show something which might look chaotic at first but is quite interesting. Let's have a look. This is Conway's Game of Life, or simply just life. It's a type of cellular automation first put forwarded by the British mathematician John H. Conway in 1970. This near lifelike thing has theoretically the power of a universal Turing machine, that anything which can be computed algorithmically in this world can be computed within the game of life. Well, this is essentially just a grid or simply a table filled with zeros and ones in the cells. Each of these cells can have only two states, that is, either alive or dead, which is determined by the population of its neighboring cells. And everything else depends upon these four rules. Any live cell with fewer than two live neighbors dies, as if by underpopulation. Any live cell with two or three live neighbors lives on to the next generation. Any live cell with more than three live neighbors dies as if by overpopulation. Any dead cell with exactly three live neighbors becomes a live cell as if by reproduction. So by keeping only this in mind, we can recreate the game of life in any programming language. In my case, it is C. So now we need tables, or rather two-dimensional arrays. The first one would hold the initial states of the cells. Next, we would iterate through all these cells individually and calculate the population of its neighbors. Then by using these conditional statements, that is our rules which I had previously mentioned, in the second table we would place the new configuration of all the cells. Then table 1 will be assigned with table 2's values, and table 2 will be cleared and will have only zeros in it. Now by using OpenGL, Metal, Vulkan or any other graphics API, we can display the grid on our screen. Provided with a large memory and a lot of processing power, you can even simulate the whole game of life inside the game of life, as I had earlier said that it is Turing complete and is capable of implementing any algorithm in this world. It has even got its own implementations in the fields of biology, physics, mathematics, and generative sciences, to name a few. The source code of the playground is publicly available in a GitHub repository. One can take a look if interested. Well, that was it about the game of life in 180 seconds. Thank you for watching.
Hello, I'm Angshuman Banik of class 7. and today I am going to show an experiment based on cybersecurity. It is more like a social awareness to give you all. You can see that this tiny looking pen drive thing, what it can do today I am going to show you. It can totally compromise or hijack or hack, you can say, your system. Here is the diagram attached to it. So let's move on to our practical. So this is our victim machine with Windows 10 running, and here is our hacking machine or the Kali machine waiting to get the metadata connection so that we can have the full access to this victim machine. Now when we will insert our pen drive, now we are going to see that something very fast is happening here. Something very fast happened. The Windows PowerShell box opened, and it popped out. Something that very fast happened. Now, after that, very fast, in matter of second it happened. We will be seeing that. Now we can see here that a Meterpreter shell opened. Now we can literally control this Windows machine over here. So now what we will be doing? So first of all, we will type the system info, what we are handling. We have to see that. So sys info, and we have Windows 10 64 byte 86 Windows. You can see desktop, this is the model name. We have literally everything. Now if I type help here, help, we have a set of commands. We can do everything. We can now use webcam snap to take a screenshot, to take a snapshot from the specified webcam. So let us try that. Webcam snap. Let's see what's happening. It's starting, and here it has taken a photo of me. You can see right here we have our own image. This is how we can totally control. We have just taken a webcam snap. Now we can create files like webcam list. We can list the webcams, how many webcams are there. We can play audio, we can get system, and many commands we can run. We can also use the key here, screen share or screenshot, to grab a screenshot from the hacked, compromised machine. So let's do that. Screenshot. Here our screenshot is saved in this directory. We can do more thing. We can later on upload a Trojan into it, so that when we will upload a Trojan, it can completely destroy this system. So that is it for the practical. So that is how this attacks carries on. You have seen how fast it goes and how we have our whole control. So how do we protect? How do we prevent it? So the option is use a Microsoft approved app known as Penetract Disguised Keyboard. That adds an extra layer of security. Whenever a keyboard or in these kinds of attacks, the pen drive that I showed, it acts as a keyboard and send keystrokes. So we know that pen drive should act as a storage device, not a screen, not act like a keyboard. So whenever we insert a keyboard like thing, it freezes the screen and tells you to enter the password to use it. So you get prevented from it. Now what will happen if you insert your keyboard to that? It will again freeze the screen and you have to give the password. And you have to also set the password when you download that app. Penetract Disguised Keyboard. So that was it. I hope you like it. Thank you.
everyone, my name is Ritrisha Yogi and I'm from class 10. Today my project is about motion activated robot. No matter what, we are always fascinated about robots. So here I have something to show you. Well, how does it work? The robot can detect infrared light, which is a type of electromagnetic radiation. Humans can only see a small part of the electromagnetic spectrum, that is visible light. But there are many other types of electromagnetic radiations like radio waves, X-rays, etc. Infrared light is given off by warm objects like a human body, red hot objects, the sun, etc. But it is just outside the range of what humans can see. This robot relies on a special type of sensor called a passive infrared sensor, or in short, PIR sensor. PIR sensors are designed to have a very wide field of view, so in order to limit its field of view only to its front, I have used a roll of thick paper. The sensor gets triggered only if the object in front of it is moving and not stand still. Here is the circuit diagram of the module. The batteries supply a voltage, let it be Vbat, to the circuit. When the switch is closed, V1 equals to Vbat. And when the switch is open, V1 is floating, so the circuit does not receive any power. The PIR sensor receives power from its VCC pin and is connected to the circuit's ground through its GND pin. The sensor is digital. It outputs a logical low or high from its out pin depending on whether or not it detects motion. A low signal is 0 volt and a high signal is approximately 5 volts. The three pins of a MOSFET are called the gate, drain, and source. A voltage is applied to the gate pin in order to control the flow of current between the drain and source pin. When a voltage between the gate and source pins is below a certain limit called the threshold voltage, no current flows. And a voltage between the gate and source pins exceeds the threshold voltage, the MOSFET begins to conduct, allowing current to pass through. For this robot, the MOSFET's gate voltage is controlled by the PIR sensor's output. However, 5 volt is above the MOSFET's threshold voltage. So when the sensor goes high, this turns on both MOSFETs. This allows current to flow through the motors and the robot drives forward. The MOSFET used in this project is an N-channel MOSFET which requires a positive gate voltage to turn on. Finally, each motor has a diode connected across its terminals. Motors can create large voltage spikes when they abruptly come to a stop. The diodes furthermore help prevent damage to the MOSFET by safely discharging the current generated by the voltage spike. So that's it. Thank you everyone. I hope you liked it. And happy Saraswati Puja to all of you.
Happy Saraswati Puja. I am Shumedha Rai
and I am Dibhuti Mukherjee.
Today we are going to discuss about pancreas. Unlike all other glands in our body, which are either exocrine or endocrine, pancreas is both. Pancreas secretes enzymes which are poured into ducts, as well as it secretes hormones which are directly poured into the bloodstream. That is why it is known as an exoendocrine gland.
Now let us talk about the location and structure of pancreas. Pancreas is an elongated organ located across the back of the belly behind our stomach. It is approximately 15 cm long. It is light tan or pinkish in color and is shaped like a flat pear.
Specialized cells in pancreas called islets of Langerhans secretes two major hormones, insulin by delta cells and glucagon by alpha cells. About glucagon, there are many times when our body requires excess energy to do some work or during an emergency. Glucagon at these times converts the glycogen stored in our liver to glucose, which is oxidized to form energy.
We all are familiar with the word insulin, isn't it? Insulin is secreted by beta cells. The hormone insulin checks rise of sugar level in blood in two ways. It promotes glucose utilization by body cells, thereby reducing the sugar level in blood. It stimulates deposition of extra glucose of blood as glycogen in liver and muscles. Under-secretion of insulin causes diabetes mellitus or hyperglycemia. Thus, a diabetic person has high concentration of sugar in blood, excretes a great deal of urine loaded with sugar, feels thirsty because of loss of water through too much urination, loses weight and becomes weaker and weaker. Oversecretion of insulin results in low sugar level in blood, and even in some cases the patient may fall unconscious. This is called insulin shock or hypoglycemia. In such cases, a prompt bite of sweet biscuit or sweet candies is very helpful.
In the exocrine part, pancreas secretes many enzymes called pancreatic juices. They are transported through the common bile duct to the small intestine where they carry out many digestive actions. For example, trypsin acts on proteins and peptides to convert them into small peptides and amino acids. Pancreatic amylase acts on starch to convert them into maltose, stearin on emulsified fats to convert them into fatty acids and glycerol.
So this was all about the pancreas, an important gland which plays a vital role in the human body. We hope that you all have enjoyed this topic very much. Any kind of fault is highly regretted. Thank you.
Thank you.
I am Pushka Datta.
And I am Kedarnath Singh. We read in class 10.
Today we are showing how 3D glasses work and why does the brain thinks the 2D pictures to be 3D.
3D basically stands for 3 dimensions. Here, 3 dimension means a particular object must have length, breadth and height. For example, 2D shape like rectangle has only length and breadth. But when we stack one rectangle upon the other, the shape which is formed now has a height. We name that shape as cuboid.
The 3D glasses do the exact same work. It was invented by Kenneth J. Dunkley. The 3D glasses helps us to view a 2D object as 3D. Let's do an experiment. If we close our right eye and try to see the 3D glasses kept in front of us, it appears at a particular position. But if we close our left eye and try to see the glasses again, it appears at a completely different position. Now it's the work of our brain to put both the images together and produce one image. Thus, when we see an object with both the eyes open, it appears to be at a particular position. This helps us to know the height of the object as well as how far is the object from us. This is known as depth perception.
A 3D technology plays around eye science to make things pop out of our screen. It lets one eye to see one image and the other one to see a different image. And thus our brain gets sticked and it is bound to produce a 3D image. Now see these images that appear in your screen. These pictures look kinda hazy, but it is the pictures which appear to have 3 dimensions when we wear the 3D glasses. So if you take off your 3D glasses during a 3D movie, your favorite character may appear hazy, but if you wear it again, it looks like the character is popping out of the screen. Try this the next time when you go to watch a 3D movie.
The red film helps to block the red light coming from the picture and it only causes us to see the blue light. The blue film helps to block the blue light from the picture and it causes us to see the red light. Thus, as mentioned before, the brain gets tricked and it is bound to produce an amazing 3D image.
The glasses which is placed in front of us, are made up of chart paper and two different color plastics.
The 3D glasses are same as sunglasses. Instead, the films used in the sunglasses are replaced with red and blue films. So, this is the science behind the 3D glasses.
Hope you all like this experiment. Thank you.
A very good morning to all of you. Myself Pragya Pal from class 10 and I am a student of Aurobindo Padbhavan English Medium. On the occasion of Saraswati Puja, our school has organized a science exhibition and here I have tried to demonstrate the electroplating of a substance with copper metal. So here goes the process. Some water is poured into the vessel. Anhydrous copper sulfate is poured and mixed well with a spoon. I have already connected the positive and negative terminals to the battery. Now, the pure block of copper is made the anode and the article to be electroplated, which I have taken as a coin, is made the cathode. Connect these two to the alligator clips and dip it in the solution. After 5 to 10 minutes, the copper ions from the pure block of copper comes to the solution and finally gets electroplated in the cathode where the coin is kept. As it is the nature of the electrode, the copper metal only dissolves. Otherwise, we would have obtained hydrogen gas at the cathode. Electrolyte is used as copper sulfate so that the copper metal can come and get plated on the. Initially, we get a black coating due to impurities, but as soon as it is removed and we clean the coin, we get the coin beautifully electroplated by copper. Here one important factor is that as the anode keeps on dissolving, it loses mass. This was the whole process. Electroplating has a large number of uses. For example, firstly, it is used as decorative purpose where brass metals are electroplated with silver to give them an expensive and shining appearance. Secondly, it is used to prevent objects from getting corroded, especially in case of iron rusting. So this was an amateurish attempt with the limited resources in our disposal. Hope you like it. Thank you.
Good morning teachers and my seniors and juniors. So today for the science exhibition I am exhibiting an anti-gravity wheel which would require the following materials. Two CDs, one of a smaller size and one of a normal size, a motor, a switch, a LED which is optional, battery maybe of 9 watt and a wire to be connected with parallel circuit and soldering iron. This is the circuit diagram through which I've made the anti-gravity wheel. behind this anti-gravity wells mechanism is Newton's law of motion, which is on the moment of force and torque. Actually, this small CD is kept as it is responsible to be functioning as a counter torque, which is used to balance this bigger CD and not falling on the ground. So when these two CDs are placed stationary without switching on this, that time it would just normally fall on the ground. But when the switch is turned on, it appears that it rotates all around without falling on the ground. When this counter torque is spinning, when the switch is turned on, due to its mass, it makes it precise rather than falling. But when we will measure it, when it's stationary, the weight, and when the switch is turned on, that time's weight, they both will be completely equal. Like this smaller CD is not reducing this weight, but it's balancing it by moving on the direction that is opposite to the gravity's force. The gravity and this are becoming equal, and the resultant is getting zero, and this is why it doesn't fall on the ground. Thank you.
Good morning to our respected teachers and my dear friends. I am Rehan Chaki of class 7 and I have made a hydraulic arm which can easily lift up any lightweight object. So, I have used cardboard, syringes, safety pins and some pieces of plywood. And yes, saline pipes too. So, this red syringe is connected to this syringe, which will help it to move right or left. And the green syringe is connected to this green syringe, which will help this whole structure to move up or down. And this blue syringe is connected to this blue syringe, which will help the second layer, I mean by the first layer, to move up and down, something like this. This one is coming down and up. And the yellow syringe is connected to this syringe, which will help this whole structure to open its hand and close it. So, let me show you how it works. So, as you can see, the structure can easily lift up this light-weighted glass and place it, and again it can lift it up. So it can also move it and keep it too.
Hello everyone, my name is Shuja Roy and I read in class 9. My project mainly shows the Brachistochrone problem. The Brachistochrone problem is a hugely important problem in the world of variational calculus and classical mechanics too. This problem was first posed as a challenge by Johann Bernoulli in 1696. The brachistochrone comes from the two Greek words brachistos meaning shortest and chronos meaning time. It describes a problem in which we are given with 2 points A and B. And the idea is that under the influence of gravity, what is the shape of the path between these 2 points such that an object rolling down this slope takes the least time. One might choose a straight line joining these 2 points, but remember it is about the shortest time, not the shortest distance. In 1697, Johann Bernoulli came up with the answer using a very clever approach, that is, the Snell's law. The Snell's law states that the ratio between the sines of these two angles equals to the ratio of the speeds across these two media. Light always obeys Snell's law when its speed changes. Light refracts according to Snell's law. In other words, it always follows the path that is fastest for it to take. Johann Bernoulli used this fact to tackle the brachistochrone problem. If we see that the path followed by light when it moves from denser to rarer media and then rarer to more rarer media, what is observed? Well, it is brachistochrone curve, the curve of least time. The curve can be described in other way. Roulette, specifically a cycloid. In mathematics, the path traced by a point on a rolling object is called a roulette. The roulette traced by a point inside a disk is called a trochoid. Now, a trochoid can be curtate or prolate, depending on the position of the tracing point, whether it is inside or outside the disk. But if the point is on the circumference, the resulting curve is called a cycloid. A cycloid satisfies Snell's law, and that is the brachistochrone curve, the curve of least time. For the following experiment, I have used pieces of cardboard, glue, and marbles. Here is the practical demonstration of the brachistochrone curve.
Good morning everyone, my name is Shankalpa Chakraborty, I am from class 8 and today in this science exhibition I am gonna show you the formation of image by convex lens. So there are some terms that we are gonna use in this experiment. So first term is refraction of light. Refraction of light is a phenomena due to which a ray of light deviates from the path at the surface of separation of two optical medium. The next thing is real image. Real image is an image that can be taken on a screen. The real image is always inverted and it is formed at the opposite side of the object. Now virtual image. Virtual image is just the opposite of real image. Virtual image can be taken on screen. It is erect but laterally inverted. Laterally inverted means the right side of the image appears to be left side and vice versa. And virtual image is formed on the same size as the object. Now another thing is lens. Lens is a transmissive optical device that focuses or disperses a ray of light. Next point is focus, focal point. Focal point is a point on the axis where rays parallel to the principal axis meet at that point is called the focal point. And next in the center. So these are the parallel rays and this is the lens. So after refraction all the rays meet at this point. So this point is called the focal point. And now center of curvature. Center of curvature is the center of the hollow sphere of which the lens is part of. Center of curvature is double of the focal point. So if the focal point is here, the center of curvature will be double of its length. That means here. So if the focal point is f, then the center of curvature will be 2f. And there are some formulas that we are gonna use. So first formula is for finding the position of the image. For finding position of the image means using this formula we will find where the image will form and the point where the image will form. So this formula is 1 by v plus 1 by u equal 1 by f. Here v represents the image distance, means the distance where the image will form. U represents the object distance, where the u means the distance where the object will be there, and f is the focal length. So, and now there is another formula. This formula will use for defining the size or magnification of the image. So this formula is L1 by L2 is equal to minus V by U. Here L1 means the image size and L2 means the object size, and V is image distance and U is object distance, and minus here represents if the image formed is inverted or erect. And this formula we can conclude this formula from the similar properties of triangle. Now I have divided these experiments into 3 main cases and 3 sub cases. So I am going to show you the first case. The first case of when the object is at the infinity. When the object is at the infinity, we know it always sends parallel beam of light. So here these are parallel beam of lights. This is the axis. They are all reflecting and forming at the focus. So now we are checking if this is right or wrong. So for that, find the position of the image. Position using this formula. Then 1 by v plus, since the object is at infinity, plus 1 by infinity equal 1 by f. Then by doing this equation, we get that the image will be forming at focus and v will form at focus. Okay. So another part. Now we'll find the size or magnification of the image. Same using the another formula, L1 by L2 equal minus V by U. Here L1 is the size of the image and L2 is the size of the object. Okay. So here L1 and L2, and image is forming at focus and object is at infinity. So f by 0. So f by infinity, that is L1 by L2 equal minus 0. So the image will form at, will be very highly diminished, means will just a point. And minus here represents the image is inverted. So from doing this equation we can find some characteristics. The image is real, the image is inverted, the image is highly diminished, and it is formed at focal point. Now case 2. Case 2, when the object is at center of curvature. So here is the object, it's 2f. 2f means double of center of focus. Center of curvature is double of focus, so it's 2f. So it's coming from here and it is forming at center of curvature. Now finding, so 1 by v plus 1 by u equal 1 by f. So here 1 by v plus 1 by 2f equal f. So doing this formula, we can, doing this equation, we can find that the image will be forming at center of curvature. Now we will find the magnification of the image. So L1 by L2 equal minus v by u. So here image distance is 2f, object distance is also 2f. So L1 by L2 equal minus 2f by 2f. So L1 by L2 equal minus 1. So in doing this equation, we get that L1 equal to minus L2. So the image size and the object size will be same. Now the properties, the image is real, of course it can be taken on screen. The image is inverted, the image is of the same size as the object. The image is formed at the center of curvature, that is at 2f. Now the third case. Third case is when the object is at focal point. So here the object is at f and this is the thing that will happen. So now finding the image will be at 1 by v plus 1 by f equal 1 by f. So doing this equation, you can see that the image will be formed at infinity. Means it will form a very high, large distance. Now finding the magnification of the image. So L1 by L2 equal minus infinity by f. So L1 equal to minus infinity. That means the image will be highly enlarged. So the properties are, the image is real, the image is inverted, the image is highly enlarged, the image is formed at infinity. So now there are some sub parts, that 3 sub parts that also we are going to show. So first part is when the object is between infinity and center of curvature. So here is the center of curvature and here is infinity. So object is between here. Then the object will be formed at between center of curvature and focal length, and it will be smaller in size and erect and real image. Now another is when the object is between principal focus and center of curvature. So it's between principal focus and center of curvature. Here the image will be enlarged. It is formed beyond center of curvature but not at infinity. Okay. So now there is one last case that I'm gonna show. That is when the object is between pole and principal focus. So this is the pole and this is the principal focus. So object is between pole and principal focus. That means the object is here. So from here the image that will get, because here the line are it will not converge, but this side if we take, it will form a virtual image that is enlarged and it's virtual. So these were the 6 cases that I explained. Here is the first case when the object is at infinity. So the image will form at focals. Okay, so now I'm switching off the flash so that we can see the image. So as you can see, the image is very small and it's just taken on a screen, so it's real image and it's inverted. Now case 2. Case 2 is when the object is a center of curvature. So now the image will also form at the center of curvature. Okay, so the image is of the same size as the object, it is inverted and it's real. Now case 3. Case 3 is when the object is at focus point. Okay, focal point. So the image will be formed at infinity. So as you can see, the image is forming here. Okay, so it's highly enlarged and it's inverted and it's a real image. Now the fourth case is when the object is between infinity and center of curvature. So the image now will form now the image will also form at between center of curvature and focus. The image is smaller in size, it's inverted and it's real. Now third case is when the image is between center of curvature and focal point, focus. Okay, so now the object will form beyond center of curvature but not at infinity. It's enlarged in size and it's inverted and it's a real image. Now case 6 and the last case. The last case and the case 6. The case 6 is when the object is between focus and the pole. That means it is between the lens and the focus. Okay, so now as you can see, we are not getting any image on the screen. It's a very blurred image, so we can't get on the screen. But the image now will be a virtual image. As you can see, it is forming a virtual image that is behind the mirror. Okay, so it's enlarged, it's laterally inverted, and it's a virtual image and it cannot be taken on a screen. So thank you. So this was my experiment. I tried to show the formation of image by convex lens. So thank you all and have a great day.
Good morning all, I am Srijita Pal. I am Srijita Chakraborty. We are the students of class 9. Today we are going to show you 2 different experiments from the fields of physics and biology. Now let's start. At first we are going to start with our first physics model. This is our model which is about hydraulic press and it is based on the principle of Pascal's law. The ingredients used here are cases, aluminium sticks, 1 cardboard, 1 small car, 2 syringes, hydraulic fluid and one thin pipe. The mechanism here is when we push the plunger of the syringe A, the fluid from syringe A moves to syringe B and the pressure generated in the fluid pushes the plunger of the syringe B backward, due to which the base moves up. And on the other hand, when we pull the plunger of the syringe A, the fluid from syringe B gets transmitted to A and the plunger of syringe B moves inward, due to which the base moves downward, that is, it attains its initial position. This hydraulic press is used in different places like in garages for lifting pick cars, etc. So this is the entire mechanism. Now we are going to show you the biology experiment on the working model of diaphragm. This is our model. To complete this model, we have used one plastic bottle, one Y-shaped plastic pipe, black tape, two small-sized balloons and one large-sized balloon. Here, in this model, the plastic bottle itself is the rib cage and the empty space inside the plastic bottle is our chest cavity. The Y-shaped plastic pipe is the trachea, through which the air will go inside and will come out. The two small-sized balloons here are our lungs and the one large-sized balloon is our diaphragm. Below the lungs, we can see a muscular sheet which is known as the diaphragm. The up and down movement of diaphragm helps us in breathing. Now, what is breathing? The process of taking in oxygen and giving out carbon dioxide is known as breathing. It is a physical process and involves two steps, inhalation and exhalation. The process of taking in air, rich in oxygen, is called inhalation, and the process of giving out air, rich in carbon dioxide, is known as exhalation. One inhalation and one exhalation makes one complete breath. Now, from this model, we have observed that on pulling down the string of the purple balloon, the two small-sized balloons inside the plastic bottle expands as air goes into them. But when the string of the purple balloon is released, the two small-sized balloons inside the plastic bottle contracts as air is expelled out from the balloons. Now from this model, we can conclude that during inhalation, the diaphragm contracts and the air enters the lungs, as a result of which it expands. And during exhalation, the diaphragm expands and the air is expelled out, which causes the lungs to contract. So this is the end of our two experiments, and thank you all.
Hello our respected viewers. Today in this part of the video we are going to learn and see what is total internal reflection. But before we start, we would like to introduce ourselves. Myself Shanitya Chaudhary of class 7.
Myself Shoikat Roy. Wish you a happy Saraswati Puja.
For those who don't have a clear idea of what is refraction, we would like to define it as
refraction is a scientific phenomenon which occurs when a ray of light from an optical medium passes through two media having two different densities.
Now we shall see the clear demonstration of refraction, grazing emergence, and total internal reflection.
When a ray of light from an optical medium passes to a denser to rarer medium, the ray of light bends away from the normal. This is called the normal, and this is the incident ray, and this is the refracted ray. This is called the angle of incidence, and this is called the angle of refraction, and this is the angle of deviation.
Again we have the normal. This is the incident ray. This is the refracted ray. Here you can see the angle of incidence is increased, and on increasing, what do we see? We see that the angle of refraction also increases, and it is not so far from the line of contact. And next we see what is grazing emergence. Grazing emergence is a condition in which the refracted ray grazes along the line of contact of the two media. Here the emergent ray or the refracted ray is perpendicular to the normal.
And on further increasing the angle of incidence, the refracted ray grazes along the surface of the denser medium. The angle of incidence is called the critical angle, and the angle of refraction is equal to 90 degree. And there is one condition that of grazing emergence, that the angle of incidence should be equal to the critical angle, and the incident ray should pass from a denser to rarer medium.
Now, there might be a question in your mind that what is a critical angle? So, a critical angle is that particular angle if the light ray is incidented on the critical angle, the refracted ray should graze along the line of contact of the two media. In simple terms, if the angle of incidence is equal to the critical angle, it will form grazing emergence. The critical angle stands different for different media.
Total internal reflection is a phenomenon of light that occurs when the refracted ray is more than the 90 degree, and as such it gets reflected in the denser medium, and no light energy is absorbed by the denser medium.
Here, this is the incident ray and this is the angle of incidence. You can see the angle of incidence is huge, and so the refracted ray, instead of getting refracted in the rarer medium, it gets reflected back in the denser medium. Here you can see this is the angle of refraction, which is more than 90 degree. Here there is one more condition, that is the angle of incidence should always be greater than the critical angle.
Good morning, respected principal ma'am, all the teachers and my dear friends. Today, I, Shobik Devnath of class 7, is going to show an experiment which proves that salt does not conduct electricity, whereas salt water can conduct electricity. I have made a circuit where there is a battery and a connector. One end of the connector is connected to a foil paper which is surrounded around ice cream stick, and the other end is connected to a bulb. Now, if we put the two ends of the circuit into the salt, we can see that the bulb does not glow. But when we put it into the salt water, we can see that the bulb glows. This is because salt does not conduct electricity, as the sodium and chloride ions present in the salt are not broken down still. But in water, the salt is broken down into sodium and chloride ion, which increases the power of conductivity of the water. Thus, the bulb glows in salt water. Thank you. Thank you.
Hello everyone, my name is Ahona Mukherjee from class 8. Today I am going to share with all of you a nice experiment from where you all are going to know what happens when there is a cut of oxygen. So for this experiment we are going to need a bowl, a glass, some sort of water and a candle which is burning. So the first step which we are going to follow for doing this experiment is place the glass over the candle which is mentioned here. So first we are going to place this glass over the candle, this one. So we will place this glass over the candle like this way and let's see what happens. So the moment when the candle stops burning, you can see the water has also got into the glass. This is just because of when the volume of the air decreases, the water rises, and also there is a cut of oxygen, for that the candle has stopped burning. This is why this experiment proves that when there is no oxygen there will be no burning. So we are also going to know brief about it from the chart, that when the oxygen is depleted, the candle goes out and the air cools. The volume of the air decreases and the water rises. The temperature temporarily change delays and the rise of water. As several readers have pointed out, also the water condensation should be mentioned. While water is initially gas, it condenses and helps to relay the effect. Thank you, and also you can try this experiment at home. Thank you.
I am Mrigonabo Shaha of class 8. Today I am going to exhibit my science project on the topic fire alarm. So, as I take the fire near this, the red LED glows, and as soon as I turn off the fire, the red LED also turns off. So, why does this happen? Actually, fire alarm is based on the principle of the bending of the bimetallic strip. In the fire alarm, the bimetallic strip acts as a switch of the circuit. As you can see, there is a small gap between the wire and the bimetallic strip. So, when I take the fire near the bimetallic strip, see, it bends due to the unequal expansion of the two metals in the bimetallic strip, and as a result of the bending, it touches the free terminal of the circuit, which completes the circuit, and the red LED glows. As soon as I take the fire off, the bimetallic strip contracts and the circuit breaks, and as a result the LED turns off. This circuit could be improvised by using a sound alarm. Thank you for giving me your precious time to show you my science project. Have a nice day.
My respected teachers and my dear friends, I am Trishanjan Cope of class 7. I have made a hydraulic weightlifter that can easily lift a weight of a glass full of water. So here we have four syringes, two here and two here and one present in the hydraulic weightlifter and one here. So first we will talk about our blue syringe. So these two syringes are connected with a pipe, that is this one. So as we know that water is incompressible, so when we apply force in this blue A syringe, let's think this syringe is A and this is B. So when we apply force in this syringe A, the water moves from here through this pipe and goes into here, and the water applies apply force into this syringe and our weight got lifted. The same thing happens with this green syringe too, but blue syringe lifts the weight and this green syringe rotates our hydraulic weight lifter. So now I am going to show you. This is our glass tray of water. So I have added a little color into it so that the water can get visible. So I am applying force into this blue syringe. You can see our weight is getting lifted by the force of the water. So now I will apply force in this green syringe. So you can see that our hydraulic weight lifter is getting moved from this direction to that direction. So when we will pull back this syringe, it will suck all the water present in syringe B, and our hydraulic weight lifter will come back to its original place. So you can see it is sucking all the water present in syringe B, and our hydraulic weight lifter has come back to its original place. The same thing will happen with this blue syringe. You can see our weight has come down, and this is my project. Thank you.